Hey guys, welcome to Chapter 3, Lesson 3.1, Solving Quadratic Functions. So in this lesson, we're going to solve quadratic functions by graphing algebraically, which just means solving, and then using a real life problem. So here are our three types. So by graphing, what we're looking for are the x-intercepts. That is your answer. You're just looking for the x-intercepts. Using square roots, we are going to take an equation like this where u is an algebraic expression and solve by taking the square root of each side. So when we do that, I just want to show you kind of what that looks like. So if we have u squared equals d, I'm just going to use what they have right here. And we take the square root of both sides. What ends up happening is we get u is equal to plus or minus d. So because our squares and square roots cancel each other out, just like adding and subtracting cancel each other out, multiplying and dividing. So they are inverses. Squaring and square roots are inverses. But we don't know if the number for d is positive or negative, therefore we have to show both options. And then we're going to write our equation in this format to factor it. So let's go ahead and get started. So we're going to start with our first questions, solving by using square roots. So we're going to solve this just like we normally would an equation. Our goal is to get it to just x squared. So in order to do that, I would need to add 31 to both sides. So that would leave me with 4x squared on this side and 80 on that side. So I still need to get it down to x squared, so I need to get rid of the 4. I can do so by dividing. And I get x is equal to x squared is equal to 20. I'm just trying to skip a step there. All right, so now, let me just, in case this little dot is confusing some people. All right, so now is where we want to find the value for x. So we take the square root of both sides because squaring a square root cancels each other out. So now we have x equals plus or minus the square root of 20. But we're not going to leave it like that. And we're not going to put it into a calculator and get a decimal because this does not tell me to round to any decimal. So we're going to simplify it. All right, and hopefully we have talked about this in class by the time you're doing this lesson. All right, if not, we will talk about this as a group, so no worries. Okay, so what does the square root of 20 equal? So we have to think about two values of 20 where one of them is a perfect square. So two numbers that you can multiply together to get 20, one is a perfect square. So if you thought about 4 times 5, great idea. So now we can find the square root of 4. That is 2, and we're doing 2 times the square root of 5. So our answer is plus or minus 2 the square root of 5. So technically our solutions are positive 2 square root of 5 and negative 2 square root of 5. So we do have two solutions. All right, so I want you guys to pause the video and I want you to give B a try. I just want you to solve it down to at least x squared equals. All right, so please pause your video and give that a try now. All right, so hopefully you gave it a try. You got down to this step and at least maybe went one step further. So we take the square root of both sides, all right, to undo the square. However, I have a negative here. So because of this negative, there is no number that if I multiply it to itself will ever give me a negative answer. So the square root of a real number cannot be negative, so this has no real solution. I'll write that down for you. So maybe you're like, why did you say no real solution instead of just no solution? We are going to learn about that in lesson 2. So something to look forward to. Why is this called a real solution and not just solution? All right, so moving on to C. So I know y'all see a fraction there, you automatically get scared, but we can get rid of this fraction by simply multiplying by the reciprocal. So if we multiply that side by the reciprocal, we got to multiply this side by the reciprocal. Why does that work? Because 5 times 2 is 10, 2 times 5 is 10, 10 divided by 10 is 1, so those cancel each other out. leaves us with x plus 3 squared equals, well, you could think about that as a fraction. So 5 times 5 gives you 25 over 1 times 2 gives us 2. So now we're going to take the square root of both sides because we're down to that part. And yes, I know it's a fraction, and yes, it is okay. So I'm going to separate those in my answers. So now we have x plus 3 equals plus or minus. So with a fraction, when you're taking square roots, you take each part separately. So you take the square root of the numerator, take the square root of the denominator. You don't do it together. However, in math, we have another rule. I know y'all love them. Where in your denominator, you cannot have a square root. So we have to get rid of this square root. So I'm going to show you how to do that up here. All right, I'm going to write in a different color just so it doesn't mix in. So we have the square root of 25 over the square root of 2. So I know right now that the square root of 25 is 5. So I'm going to go ahead and simplify that. Now, how can I get rid of this? Well, I need to make it a perfect square. So I need to know what number can I multiply to 2 to make it a perfect square. So maybe you said, oh, 2 times 2 is 4, and 4 is a perfect square. So we're going to multiply this by the radical. But in order to do that, I have to also do it to the top. Because remember, any number divided by itself is 1. So this is essentially like multiplying by 1. So why did I do that? Because now I end up with 5 times the square root of 2 over the square root of 4, and I can actually find the square root of 4. So what is the square root of 4? We said earlier that the square root of 4 was 2. So now I'm able to take this answer and put it in this spot, okay? And I no longer have a radical on the bottom. I know that was weird, but hopefully by the time you work on this lesson, like I said, you have practiced some of this and feel a little more comfortable. All right, so we got plus or minus 5 square root of 2 over 2. Now we still have to, why does that look weird like that? Oh, come on, Miss Gill, get with the program. All right, so we still have to solve for x. We can't leave plus 3, so we're going to subtract 3. All right, when we do these though, because of this whole plus minus thing, it makes your life a little easier to just bring that minus 3 to the front. And then we have plus or minus 5 square root of 2 over 2. So we can't actually combine these together. We can't add 3 with this because you have to have the square root in order to make that happen. So technically we have two solutions. We have x is equal to negative 3 plus 5 square root of 2 over 2. And we have x is equal to negative 3 minus 5 square root of 2 over 2. Now at this point, if you could combine them, I would want you to combine them here, okay? So again, if you get to working on this lesson and this part trips you up, I will be happy to work with you on some of the questions like this. Or just working with the radicals if that's what you need, all right? I will work with whatever you need help on. All right, let's move on to example 2, solving a quadratic equation by factoring. So in order to solve a quadratic equation, our first step is always to set it equal to 0. So I need to take this 45 and I need to move it to the other side. All right, how can I do that? I can subtract it. 45 minus 45 is 0. So I can make this x squared minus 4x minus, okay, lady. Like my brain or hand is working quicker than my mouth. I don't know. Minus 45 equals 0. So we need to factor this. We need to set it into two parentheses like this. Okay, so in the past, I'm not sure how your teachers taught you because some teachers say different things. You may have been taught you need a product that is negative 4, whose sum is what? Let's try that again. The product of negative 45, whose sum is negative 4. I have a hard time remembering product and sum just in this situation, probably because my teacher taught me multiply add, and so that's just like drilled into my head. I do know Ms. Zutel says product and sum, so just in case y'all have her in the future, just know that it is the same thing. All right, so we have two numbers that we need that multiply to give you 45, add to give you -4. And again, we should have practiced factoring right after teacher planning day. So we need two numbers, multiply this, add to this. Well, in order to get a negative in our multiple, that means that we must have had a negative in one of our factors. So then if your adding term is negative, that means your greater factor is the negative one. So two numbers that we can multiply to get -45 are -9 and +5. And if I add those together, I do get -4. So now I'm going to come over here to my parentheses and I'm going to put x minus 9 and x plus 5. Once I have it to this point, I'm going to set each factor equal to 0. Why? Because in order for this to equal 0, one of these had to be 0 because any number times 0 gives you 0. So we're going to set each one equal to 0 and we're going to solve. So we add 9 to both sides, we get x equals 9. And we subtract 5 from both sides, we get x equals -5. So your solutions are x equals -5 and x equals 9. I do want to point out one thing. If you recall from chapter 2, we talked about intercept form. And it looked like this. Notice that this is the same form. The reason I'm telling you this is because we're going to see on the next example that when we graph, our answers, our solutions are the x-intercepts. So just wanted to kind of get you thinking about that process. Okay, moving on to example 3, solve each equation by graphing. So in chapter 2, we reviewed how to solve or how to graph a quadratic function by finding the vertex and all that. Keep in mind that you don't have to do it the long way. You can use the graphing calculator. When you're on the computer, you can use Desmos for help. You should know how to do it without the calculator and Desmos, so this would be a good time to practice, but just know that you do have those options for backup. All right, so that way if graphing is not your strong suit, you have those technology pieces to help you. Okay, so remember, to find the x value of our vertex, we just do -b over 2a. So I'm just going to plug that in and see what we get. So if you would, go ahead, give this a try. Pause your video, find your vertex, find the y value once you have your axis of symmetry. And then we know that this -6 is an important part on our graph, right? We know that this is your y-intercept, so we already know 1, 2, 3, 4, 5, 6. So we already know that that is a point right there on our graph. So we got 1 point. We know this opens up, so that means our vertex should be below this somewhere on either side. Don't know which side yet. All right, so pause your video, see if you can find the vertex. All right, so I found my vertex to be 0.5, -6.25. So I have those points, or that point. So a half would be midway, 6 would be just below. So if I know this point, that means I also know that this is a point on my graph. But these are really tiny, so I need to expand and find another value. So I maybe would even go past 2 just because 2 is right here, just because these are so close together, and maybe try 3. So plug in 3, see what you get. So I did that and I got 0, so that means the point 3, 0 is on our graph, which means that that is an x-intercept. So if I know this one is 1, 2.5 away, then I got a half, 1, 2 on this side. And now I can make my graph. All right, so we got our graph. Sorry that that part right there got a little wonky. So what is our answer? Well, our answer is simply these x-intercepts. So 3, 0. What is this? 1, 2, -2, 0. So these are our solutions, also known as roots. So I just want you to get familiar with that word. Roots, they typically use when you're talking about a graph. How do you find your solutions? They are where your graph crosses the x-axis. All right, so our solutions or roots are x equals -2 and x equals 3. So here's what I'd like you to do. I would like you to try to graph this one. Now notice the 4x is on the right, so we do need to set it equal to 0, so you are going to need to move it that way. So your graph will technically be that. So I would like for you to pause the video now. Or actually, I'm going to do this a little differently, just because we're 15 minutes in and we still have 2 examples, even though they're not super long. They're longer than 5 minutes, and this thing does not like me if it goes past 20 minutes. So I'm going to stop this video here and make a second part for example 4 and 5. So before you start watching that next video, give this one a try, this equation a try, and even if you type it into Desmos and get the equation, or not equation, the graph that way, and see if you can find your roots or the solutions. All right, I will see you again in the next video.